Hello everyone. Good evening, good afternoon, good morning, depends where you're at. My name is Alex, and today I'm with Alejandro Mastero, my the colleague of mine, and we are going to talk about the high availability, the virtual machine high availability in OpenNebula. I think that's a very hot topic and widely discussed, so it's something that we definitely need to go through. So please ask your questions anytime, and we will address them right after a short introduction on the topic by Alejandro. So, Alejandro, the stage is yours. Please.
Okay, thank you, Alex, for the introduction. So let's jump into introduction then. Today we will go through what virtual machine high availability is in OpenNebula and why we should use it if possible. And then I will explain how we use the fencing mechanism and how we can configure this in an OpenNebula cloud. So to begin, an overview about what VMHA is in OpenNebula. It's a feature that will allow cloud administrators to minimize the service downtime in case of a host or virtual machine error. And it works basically configuring hooks, which are an element that's part of the core of OpenNebula, that will allow users to use monitoring integrated in OpenNebula to create automated tasks responding to certain events that occur either on a host or a virtual machine. And a quick note here is that virtual machine high availability is not the same as the front-end high availability, which is a different feature that will offer high availability on the control plane of OpenNebula, protecting the users and the end users and administrators from front-end nodes failures. So the key components of OpenNebula, such as Samsung, the API, the scheduler, and other components are still available. So today we are only covering the virtual machine high availability side of OpenNebula. As mentioned before, we can cover either host failures or virtual machine failures with this system. And today we will focus on the host failure part, which is when a host is detected as an error state in the OpenNebula cloud for a defined number of monitor cycles, and we will trigger automatic scripts that will move the VMs from this failed host to another compatible one within the cloud. In case of virtual machine failure, it would be possible to also configure hooks to monitor the VM state instead of the host state, and also execute scripts responding to this failure. And why do we use VM high availability in OpenNebula? One thing is to try to eliminate or remove one of the single points of failure that we can have, in this case, host. And VM high availability will decouple the services from the hardware. And so if a host goes down, then the VM will be automatically moved to another compatible host. We aim for zero-touch recovery, and so try to eliminate any manual recovery steps. This OpenNebula mechanism will automatically trigger and execute the fencing and the VM migration without user interaction, and try to provide data integrity and VM state protection. With the fencing mechanism and shared data stores, we will try to ensure this data integrity and prevent any split brain scenarios, for instance. Regarding the fencing mechanism, here we can see a basic diagram or what would happen. So here we can see that we have a front end monitoring several hosts, and when there's a failure detected, this means that the host goes to an error state during the monitoring cycles. We will wait a set number of monitoring cycles and determine that this host is actually down and is not coming back. So once we are at this stage, we will isolate the host using the fencing mechanism to make sure that it's not coming back for any reason, and avoid any, as we said, split train scenarios where we have the machine running in two hosts at the same time. This mechanism has some vendor-specific support, so this is possible to, with the different hardware vendors, execute the fencing mechanism based on the IPMI version they have, or it's also possible to just execute the fencing using SSH, as we think we will see later. And yeah, that's basically about the fencing mechanism. And then related to the configuration of the virtual machine high availability, the basic steps that we have to follow through are creating a hook that's available in the OpenNebula installations. We have already the possibility of creating this host error hook that will have this script associated. We have a template that we offer with OpenNebula installations that will trigger on the detection of a host error state in the OpenNebula instance. Once this script executes, it will, by the defined adjusted parameters, it will decide whether or not this is a false positive or not, and then execute the associated script. Then we need to also configure the fencing. So we need to authorize OpenNebula frontend to perform the fencing operation in the host that we have configured in our cloud. So this is basically giving the appropriate credentials to execute these operations on the physical machines where we have installed OpenNebula, the hypervisor. This script that I mentioned before, that we are going to execute when the hook is triggered, will have some arguments that we can define. One of them is the action to execute once we have determined that the host is actually down. We can either reschedule, recreate, or delete the machine. What we normally do for the VM high availability, what we have to do is reschedule it to another compatible host. So it will automatically get the instantiate the machine in another host using the same storage for the virtual machine. In this regard, related to this, we will need to have configured the shared storage for the hosts. So all hosts that are in this cluster, for instance, are able to access the same data store and instantiate the virtual machine with the same disk that was running in the other host. In case it's local storage, it will be a bit different. We can define the number of cycles that we want to wait until we consider that the host is actually in error state. So there's a parameter for this. We normally we first define the monitoring cycle time. So how the periodicity of the monitor for hosts. And then we define how many of these monitor cycles we want to wait until we consider that the host is not responding anymore. After, finally, we need to enable the fencing, which in the script, there are some parameters to enable this. And then we need to issue or create the command to be issued to the IPMI of the server when the host is down. So normally what we do is we issue a power off command to the server. Then, well, I think this is the basic VM HA configuration that we need to follow. And next we are going to, we have Alex back, right? We are going to Q&A that we have from the user registration form that we had. So a couple of questions that we received from there.
Right. So the first question then happens to be, what happens to RAM after a failover?
Okay, in this case, RAM for the virtual machine will be lost since the virtual machine is running in the host that failed. We are going to lose whatever was running at that point. So when failover happens, what we do is a cold migration. Since we don't have the VM state anymore, what we do is perform a migration, and the VM will boot up again from the same data store that we had before, but losing whatever was in RAM at that point. Yeah, basically that's what would happen. We cannot save the state of the RAM on the virtual machine, but we do have this as it was in the data store at the moment of the crash.
Mm-hmm.
So
Awesome.
next,
Thank you.
yeah, next
Then the next
question.
one, right? What operations should be performed on a fencing action?
Okay, so in this case, what we normally recommend, as I mentioned before, we should be executing a shutdown on a power off. And specifically, we should do a hard power off to make sure that the host is not coming back, as I mentioned before. It is possible to implement all other behaviors, maybe depending on the desired outcome. Because we have, yeah, of course, we could try to recover the server, maybe try to do a reboot, but in this case, we shouldn't be moving the VM from this host to the other. In that case, we should just leave the VM down, and yeah, we would not have HA in this case, right? So the operation recommended by us is always a hard power off, a hard shutdown, to make sure that the host is not coming back.
Good. And then the third question, is disk consistency ensured on a failover?
The mechanism will reduce the risk by a lot, but this is only one of the several configurations that one would need to apply for the disk consistency to be ensured. Other configurations could be the use of a journaling file system, which would prevent metadata corruption, guarantee the file system recovery after a crash. We also could enable the copy on write to prevent the base image corruption. And other things that we could do should be being prepared on an application level. So being prepared in case there are any failures on the virtual machine on the application level, and how to recover once the virtual machine is up and running in the other node.
Good. Thank you. So these were the questions coming from you, from attendees during the sign up for the office hours webinar. So once again, next time, if you're signing up, please feel free to fill in the question form as well, so we have more of these questions sent to us beforehand. Good. And now we will switch to the live questions from the audience. And once again, feel free to ask your questions anytime. And if you need, you can ask a follow-up question, and we will address them in a timely manner. And we have a first one. So this is about the error detection. So how is the host error technically detected, and how to make sure that the virtual machine is really no more running on the host before rescheduler. So could we address this question?
Yeah, we determine that the host is down using the monitor. So OpenNebula has a component called the monitor that will periodically check on all the components that we have in our cloud. So when a host goes down for whatever reason, maybe there's a temporary network issue, for instance, we will stop being able to monitor the host, which means that the host is no longer sending its current state to the front end. In this case, we will see in OpenNebula in the front end, in Sandstone, for instance, we will see that the host is in error state. Once this is detected, the hook subsystem will trigger the script that we discussed earlier, right? And this script will start waiting for additional monitor cycles and check the state of the host again. So after n cycles, if it comes back, the script will just exit and that's it. So the host is not down and no actions are taken. But after what we consider that's enough time to say, okay, this host is not coming back. Maybe it's, if we have some network issue, we wait 2 monitor cycles and it comes back. Okay, everything is okay. But maybe 5 monitor cycles happen and the host is not there yet, and this could mean that the host is actually shut off or whatever other problem, right? Kernel panic or any reason why the host is not sending its current status. At this point, we will trigger the script which is going to, within OpenNebula, reschedule this VM to another host. So the VM will be launched instantiated in another host using the same storage that we had from before, right? The disk. And when the failed host comes back again, it will not have the VM because we have rescheduled it, right? So the VM will not boot up in the host that failed once we have corrected whatever reason made it to fail. This is basically how it should work.
Right, and I think it's also worth to mention that the frequency of the monitoring, you can also adjust it in the 1d.conf. So if you feel that the default value is not enough and you're not monitoring it
exactly
frequently enough, you can fine tune this parameter to make sure that you have, let's say, early detection. So yeah, there are guardrails to make sure that you to avoid this split brain issue, right? Good, thanks, Alejandro. And then another one: how long it takes to failover?
Well, related to this, the monitor cycle that we have defined will take. I mean, there will be a couple of things that we should take into consideration for this, right? So first, there's the monitor and how many cycles we want to wait to consider that the host is down, right? So we will wait if we have I don't know, the monitor, the default, if I'm not mistaken, it's like 180 seconds, something like that. I don't really recall, or 30 seconds, sorry. There's 30 seconds like the default of the monitor cycle for OpenNebula. And then if you want to wait 5 cycles, then you multiply, right? And then you will have how much time you have to wait for it to consider that it is down and start executing. And then we have the time that it will take to the virtual machine to actually boot up and be available in the new host, which in this case, since we are using shared storage and we do not need to copy any files, and the VM files are already in the data store, in the appropriate system data store, we are not moving files from one data store to another. The boot time will be mostly dependent on the application inside of the virtual machine, right? How long does it take to boot up and be ready? So these are the 2 things that we should consider for this time to complete the failover. And of course, note the number of virtual machines that you have in the host at the time and how many you need to redeploy in a new host, which is really constrained to the number of scheduling operations that we have defined in OpenNebula, which is also a parameter within 1d.conf, where we can define how many scheduling actions we want to execute at once, right? And how many actions this can be defined, and of course will depend on the setup that we have, the resources available for the front end, of course.
Sure. Well, quite a a very complex answer to what seemingly a very straightforward question. But indeed, there are a lot of parameters you can fine tune, and yeah, you should do. Right. So the next question is about fencing, which is a very interesting one, right? So where is fencing configured on the OpenNebula frontend? And can you share an example?
Okay, so the fencing is configured in the front end, indeed. So what OpenNebula is going to do is that, or the cloud administrator should do, is that you have to ensure that the front end can reach the IPMI interface of the servers. So this is part of the configuration, the infrastructure configuration, right? So it needs to be the network should be prepared for this, for the front end to reach these interfaces in some way. This, of course, is depending on the scenario, would be a different configuration. And then what it will do is that the script that we have will execute the fencing command, and depending on the manufacturer of the server, we will have different tools, right? We have, let me try to share some. All right. Just a second. Okay. Okay, I think you should be able to see now a terminal where
Yes.
I am at a front end, right? So at this in this path, we will have the following scripts. So once we configure the hook, we will have the host error hook, which is this one, and here here we will instruct it, right, to use this fence host script in case that we have to perform a failover. So other parameters are here, as I had in the presentation, right, that we had other parameters to define what action to be executed, if we want or not to use fencing. And then after the script considers that the host is actually down, it will here, as we can see, execute. And yeah, we have here the hook has launched. Okay, this executes, and the file fence host that is also available in an OpenNebula installation by default will execute. And here there are some, yeah, this is defined what we need to do, right, for the fencing. For instance, we need to, yeah, edit this, yeah, remove this line. And at the end of this, we will have this example. We have here how to execute it in an ILO, which is from HP, for instance, using the fence ILO tool, which, yeah, it can be downloaded via packages in any distro. And then another option would be to use an SSH command. If the IPMI that we are using allows for it, we can just launch in this code snippet, instead launch an SSH command that would look something similar to, I think I have also an example over here of this. So it should look, okay. So I'll paste this here. So it should look something like this, right? So we, instead of using the fence tool that we can download, we will issue an SSH command to the fence IP that we had defined with the power of hard in this case, because the server that we are using uses this syntax, right? We should take into consideration that depending on the manufacturer of the server, this command could be different in that case. And this would be basically it. I hope, this answers the question without being, too specific.
Yeah,
Okay.
I think it actually answers by a margin. Right. Yeah, you have multiple possibilities, but as Alejandro already had mentioned, you really need to figure out what your hypervisors, what your servers are supporting, and then take it from there. So there would not be a one silver bullet and universal solution that suits every possible physical device. Good. Thanks for that. Thank you for the question. And then we have additional one. Is it possible to implement the HA based on VM status? And if it's possible, then how?
During the presentation, I think I already mentioned a bit about this, right? So it is possible as well, because with OpenNebula, with the hook system, we can also create hooks that trigger on VM states. So what we should do in that case is create a hook that will trigger on an error state for VMs, and then have a similar script associated, a similar script as the one we have for the host fencing and for the, well, not fencing in this case, but the script that we have for host error. Then have one to execute with this hook that should react to the life cycle of the VM in the same way, right? So if there's an error detected, we wait for a bit, and then we execute some action, which could be redeploy the VM, for instance. It could be migrate the VM as well, depending on the scenario, right? Note that in this case, we will be only looking at the VM from OpenNebula's perspective. So we don't know what the actual application on the VM is running, or how, what's the state of this application. Another option could be to use the one gate component in OpenNebula, which is a component that will allow us to respond to actions within the internals of the VM. We can program that if let's say that we have an application that has something running in a web server, and we detect internally that the web server is failing for whatever reason, then we use one gate to tell OpenNebula, okay, this is failing, redeploy this VM in another server, or do whatever operation we need to do.
Basically, it's safe to say that we are very flexible here, and we kind of provide you the hooks, the tool set, and then the ready to use script to perform the let's say the rescheduling of that VM, and from there, whatever is your case, and depends how you pretty much trigger that script. But as I like to mention, with a great power comes great responsibility. So it's considering that you have a lot of options, it's very easy to shoot yourself in the foot, and probably always double check whatever you do there. Okay, thank you. Right, any other questions? Please feel free to ask them now. And we'll be happy to answer any relevant questions for the virtual machine high availability. Additionally, I would like to mention that explore our documentation. A lot of these cases, as well as actually the hooks example and some other stuff, is in our documentation, so you can find a variety of helpful scripts or helpful tips in our documentation. So feel free to check our documentation out, and not only on the virtual machine high availability topic, but on other uh, not less important topics, right? And should you have any issues, feel free to look into the community forum, as there are a lot of OpenNebula enthusiasts as well as our engineers answering questions and helping and assisting the OpenNebula users around the globe to figure out and solve their issues. And sometimes, the issue that you're experiencing was already resolved maybe in a couple of times by the community. So feel free to search there first, and it might just save you a lot of time and resources. But same time, if there is no solution for your problem and you're experiencing that, then feel free to open a new thread and ask for help. Again, our engineers or community will help us there. Obviously, that's why it's a very good resource. If you have any questions or issues with OpenNebula, then documentation and forum, two must visit pages to fix your stuff, or just find out how something can be configured in case of VMHA. Which I would like to add that for in the case of VMHA, we have like a pretty much step-by-step instructions there how to enable that. So that, once again, documentation would be a very good place to start with that. And don't miss out our upcoming engagements, our trainings, our webinars, office hours on variety of OpenNebula related topics. So all that can be found by following the opennebula.io/webinars page. Feel free to sign up for more, and as usual, we'll be happy to see you attending. Right. So, any questions, feel free to drop them in the chat regarding the virtual machine high availability, maybe fencing, maybe the virtual machines themselves. I think, Alejandro, you've mentioned that you need a shared storage for virtual machine high availability, right?
Yeah.
Is it possible somehow to do it without it, or it's a no-go?
I mean, it could be possible, but it is not recommended, because what we are trying to achieve here is to have the minimum downtime for the VM once it goes down. So having shared data store means that we will have the same virtual machine instantiated at in the moment that we detect this issue. If we don't have shared storage, what will happen is that the VM will be within the host. So we could recreate the VM in another host with local storage as well, but we have to be aware that we will lose anything that was in the VM. Any data that was in the VM will be lost because it's in the local storage of the host. This can be useful for maybe front ends or applications similar to that, where we don't really have any data in the virtual machine, microservices, whatever, and we access the actual data from other endpoints. So in this case, yeah, maybe it's a good option. But in general, what we do for VMHA is just having shared the storage to ensure that the disk of the VM is in an accessible place when the host goes down.
Yeah, pretty much if your application that you spin inside a VM is stateless, then there might be a reason for that. But if you require any data, then shared storage is a must. I mean, obviously, majority of virtualization users are running the shared storage anyways. But there might be some cases like edge cases, right? When you have a very tiny environment somewhere at the edge and it runs some local workloads, then the shared storage is not a thing that you can find there, or maybe sometimes you do. But that all depends, right? But it's good to know that it requires shared storage in majority of the cases.
Yeah. For this, just as a note, we would have this option that I mentioned during the presentation, right? We have the option to migrate, or then we also have the option to delete or recreate the machine. So we would be using the same script, but with these options, yeah, depending on the case.
Good. Right. So I don't see any questions coming from the community anymore. So thank you for your questions once again. I hope you've enjoyed, and we'll be glad to see you next time. We had Alejandro today from OpenNebula to cover this topic. So thank you so much, and then see you next time. Bye bye.
Thank you. Bye.